Alright, so this video is week 2's practice, day 4, and it's all word problems. So let's go ahead and take a look at question 1. So take away 6 from 4 times s. Alright, so take away means subtraction, and the number 6, so I take away 6 from. Okay, so this is another prepositional phrase. It means flip the idea around, and I'm taking it from 4 times s. So it's going to be 4s minus 6. This one's pretty simple, x minus 7. So it's just x minus means subtract 7. Okay. Let's do another one. All right, let's do 3 and 4. Okay, so 3 is 1/5 of the sum of, that's a special word phrase, of 7 and x. So the sum of is addition parentheses, okay, and in that parentheses it says we're going to have x, 7 and x, and the word of means multiplication. 1/5 is a fraction, so it's going to be 1/5 on the outside of my parentheses. Okay. Number 4 reads 8 plus q. I see a trend in what I wrote. Every other one is a little bit easier. Plus means addition, so 8 added to q. Alright, let's do 5 and 6. Alright, so 5 says 2/3 of the sum of, there's a word phrase, q and 8 minus the product of 7 and g. Okay. I forgot a comma here when writing this, I believe. Okay, so 2/3 is a fraction. Of means multiply. The sum of means parentheses, and sum means adding, and this is going to be of q and 8. Minus means subtraction. Product of, the product of is another parenthesis with 7 and g in it. Okay, because product means multiply. Alright, so it's going to be 2/3 q plus 8 minus 7g. So that's why I didn't have a comma, because the product of is putting it in parentheses. Don't really need these parentheses though, so if you wrote it as 2/3 q plus 8 minus 7g, it would retain the same meaning. Okay, I said I was going to do 6 on this one, but we have run out of room, so this is just going to be number 5. This one will be 6. K squared plus the product of 6 and w plus 3. Alright, so this one, the product of 6 and w plus 3. So the product of is going to have parentheses. It's going to all be multiplied, the first two at least, 6 and w plus 3. Okay, because there was no little comma to tell me that I was done with the product of what's in the parentheses. And k is squared, and plus means addition. So here is my expression. Alright, let's go ahead and do 7. We've got enough room. Okay, 1/3 of Q is added to the product of 9 and Z. Okay, so 1/3, I know that's a fraction. Of means multiplication. So 1/3 multiplied to Q is added. So this is added to the product. That's my parentheses. Product means multiplication. So I know that what comes next, 9 and Z, is multiplied together inside parentheses. Here we go. All right, let's do another one. One sixth of the sum of 5 and m minus the product of 9 and k. Okay, so I know that 1/6 is a fraction. The sum of, this means multiplication. The sum of means parentheses with addition in the middle. 5 and m go inside, okay, minus, and then I have the product of, which is another set of parentheses, 9 and k are multiplied together. So that would be my expression. I'm going to write it again down here. I don't really need the parentheses around 9 and k, so if you wrote it this way, it would also do. Five times the sum of b and 4. So 5 times means 5 multiplied. The sum of is another parenthesis phrase with addition in the middle, and b and 4 go in my addition. So it's 5b plus 4. All right, we only have a few more left. Let's start on number 10, which reads, the product of 6 and r. So product means, and the word of, they both mean multiplication, so I know it's just 6 times r. Okay, so I'm going to read number 11. Mary is baking a cake. The recipe calls for 7 cups of flour. She already puts 3 cups in. How many more cups does she need? Well, to find that, the question is asking me to subtract. So I could say 7 cups minus 3 cups means a result of 4 cups still needed. Okay, the question is asking me to figure out how much more, okay, which means subtraction. Or I could have displayed it as I put 3 cups in, okay, how many more cups do I need to equal the 7 cups? And this is kind of a thought progression of where we're going. Right now we're kind of right here. We're just exploring the way we communicate math. And this is the opposite operation, algebraic way of expressing it, which we're going to be talking about. So I want you to see the contrast. This is what we're kind of doing right now. We're kind of dissecting a word problem, but I need to start looking at it algebraically with my opposite operation. I know we didn't really cover so much opposite operation in the Tuesday class yet. We're still in the beginnings of that, but start thinking of it this way. Okay, what plus 3 is going to give me 7 cups? That's what I'm also kind of the mindset of what I'm doing. All right, let's handle another one. Number 12, I'm going to go ahead and read it. Mike receives $87 for his birthday. He went to the sporting goods store and bought a baseball glove, baseball, and bat. He had $22 left over. How much did he spend on baseball gear? So this is asking me to subtract how much money he has by how much he had in his pocket in order to figure out how much he spent, right? So he had to have spent $65. Another way that I could express that is the $22 that he has left over plus whatever he spent would equal my 87. Look, these are opposite operations. The problem was asking us to subtract to find the answer, and we should all, in 2 seconds, get this one. But this one takes a little bit more thought. I could write it in the reverse operational style, which we'll understand when we understand our properties of inverse, which we will be going over if you're in the Tuesday class next week. And if you're in the Thursday class, you probably are going to learn it this week because you're slightly ahead. Okay? So this is the inverse way of writing it. Number 13. There were 8 roses in a vase. Alyssa cut some more roses from her garden. Now there are 11 in the vase. How many roses did she cut? Again, we could subtract the 2. We could subtract the 8 that we already had from the 8 that we have in the end and find out that it's 3 roses. Or look at our reverse operation. If she has 8 roses, how many can we add to that to get to a total amount of 11? Again, notice the opposite operation going on. Okay? All right, let's look at the last one. There are 11 dogwood trees currently in the park. Park workers will plant more dogwood trees today. When the workers are finished, there will be 80 dogwood trees in the park. How many dogwood trees did the workers plant? Well, we know there will be 80, and currently there's 11. It's asking us to subtract to find the difference in these two. So it's going to be 69 more trees. Or I could write it as addition, and if I do that, I have to say there are 11 trees. How many more do I need to add to get to a total of 80 trees? Okay, notice the opposite operation. Notice we're adding 2 parts to get the total amount. Okay, this is the algebraic way of looking at it, and we need to start gearing our mind towards that. All right, keep doing these problems till you get them. And make sure that if you have any questions that you contact me so that I can help you. And watch out for the next video, which will actually be week 3, day 1. All right, you guys are awesome. Bye.